You know, for 4.5 billion years, our planet has been drifting through what is basically a cosmic shooting gallery. Most of the time, the universe misses, but sometimes it doesn't. So let's dive into the story of Earth's closest calls and how we, humanity, are finally learning to fight back.
Just picture this. It's a totally normal Friday morning, February 15th, 2013, over in the Russian city of Chelyabinsk. People are on their way to work, kids are sitting in their classrooms, and then, out of nowhere, the sky just explodes with a light that's literally brighter than the sun. There was no alert, no warning at all, just this sudden, terrifying flash.
So what they were seeing was a 20-meter asteroid. I mean, think about the size of a 6-story building, slamming into our atmosphere at a mind-boggling 40,000 miles per hour. And the reason nobody saw it coming? Well, it came at us from the direction of the sun, which is a perfect blind spot for all of our telescopes on the ground. Now here's the surprising part. The rock never actually hit the ground. But the shockwave from it exploding in the atmosphere, it was so powerful it shattered windows across 6 different cities. And that's what injured more than 1,500 people, all from flying glass and debris. It really shows how a cosmic event can have a very real, very human cost. This kind of explosion, it's called an airburst. And the energy it released was, well, it was staggering. We're talking about 500 kilotons of TNT. To put that into perspective for you, that is 30 times the power of the atomic bomb dropped on Hiroshima. This was a massive, global wake-up call. But here's the thing, Chelyabinsk wasn't just some isolated, one-off event. Oh no, it was just the latest in a long, pretty alarming pattern that shows we've been dodging cosmic bullets for a very, very long time. Just take a look at this timeline. You see the massive Tunguska event back in 1908, but then notice how the close calls just start stacking up in recent years. In 2004, one whizzed right past us inside the orbit of our own satellites. Then in 2019, a city killer was spotted just one day before it flew by. And in 2020, another one set the record for the closest pass we've ever seen. The threat isn't just something from a history book, it's constant. So let's go back and zoom in on that 1908 Tunguska event for a second. This thing was 3 times bigger than the Chelyabinsk meteor, and it exploded with the force of about 1,000 Hiroshima bombs. It completely flattened 830 square miles of forest in Siberia. If it had gone off over a major city, say London or New York, the casualties would have been in the millions. And here's the real kicker. Scientists think these events happen every few centuries, which means we are statistically overdue for another one. And these close calls are just getting more nerve-wracking. In 2019, an asteroid big enough to be called a city killer totally snuck up on us. We only detected it a day before it zipped past. Then, in 2020, a smaller one passed even closer than our weather satellites, and we only saw it after it had already gone by. I mean, this just perfectly illustrates our dangerous blind spots. Okay, so far, we've been talking about near misses. But to really get what the ultimate stakes are here, we have to look at the scars that were left by direct hits, the kind of planetary catastrophes from Earth's deep, deep history. Just look at this chart. You can see Chelyabinsk and Tunguska way over there on the left. Tiny. Now, look all the way to the right. That is the Chicxulub impactor. It wasn't 20 meters wide or 60 meters wide, no. It was 10,000 meters wide. That's 10 kilometers. A rock the size of a mountain, moving faster than a speeding bullet. This is the one. This is the impact that ended the age of the dinosaurs 66 million years ago. It released the energy of billions of nuclear weapons, and it triggered what's called an impact winter that blocked out the sun. The result? 75% of all species on Earth gone. This is the existential threat. This is the worst-case scenario. And believe it or not, even that wasn't the biggest hit our planet has ever taken. The Vredefort crater down in South Africa is twice the size of the dinosaur one, a scar from an even older, more violent collision. It just goes to show you, our planet is a survivor of some truly unimaginable cosmic violence. So, the threat is very real, and the stakes are enormous. The big question is, what are we actually doing about it? Let's take a look at humanity's modern-day efforts to keep its eyes on the sky. All right, let's start with the good news. When it comes to the really big ones, what we call near-Earth objects, or NEOs, we've had huge success. Thanks to some really dedicated tracking programs, we have found over 95% of the truly giant civilization-ending asteroids, anything over a kilometer in diameter. And the best part? none of them pose any threat for at least the next 100 years. So we can all breathe a little easier about that. But when we start looking at the smaller near-Earth objects, the story changes completely. We have found less than half of the so-called city killers, the ones that could wipe out an entire region. That means there are potentially thousands of them still out there, right now, completely undiscovered. So when scientists do find a new asteroid, how do they tell us how worried we should be? Well, they use this, the Torino scale. It's a pretty simple 0 to 10 rating. 0 means no hazard at all. A 10 means we've got a certain collision with global consequences. Thankfully, no object has ever stayed above a 4 for very long, but these alerts are a crucial way to stress test our response systems. You know, for almost all of human history, our only defense against asteroids has been, well, luck. But that is finally changing. We are now entering a whole new era where we can move from being passive targets to becoming active defenders of our own planet. And our first big step into this new era happened back in 2022. NASA's DART mission did something straight out of a science fiction movie. It flew a spacecraft millions of miles through space and deliberately slammed it into an asteroid named Dimorphos. The goal was simple. Could we move it? And the answer was yes, it worked. We successfully changed its orbit. For the very first time, we proved that we have a viable defense strategy. That's a huge, historic achievement. So that's it, right? Problem solved? We're all safe now? Well, not quite. The reality is, our new superpower comes with some pretty major challenges. See, here's the catch. A mission like DART needs a lot of warning time. We're not talking days or months, but years, maybe even decades, to actually work. And it doesn't solve that blind spot problem that let the Chelyabinsk meteor sneak up on us. Plus, we still can't really track the thousands of smaller, but still very dangerous objects out there. So where does all this leave us? It leaves us with this really powerful idea. We're in a period of transition. We are no longer just passive victims waiting for the sky to fall. We are becoming active planetary defenders. The difference between a near miss and a catastrophe is no longer just a matter of cosmic luck. More and more, it's becoming a matter of our own vigilance, our own ingenuity, and our willingness to keep our eyes on the sky.